And let's just paste this as a value. This is important because if you change something here, it's referencing that other cell value that you got. So here we just want the number of acres. I need to move all of this up. It's fine. Bang. Bang. All right, and so here we also need to make sure that we have something that we can reference. And so let's go ahead and move this over because this is FERT. This is analysis. This is dollars per ton. And then this is dollars per pound, which is what we want, right? Okay, and it might be worth it to add that in there. I feel like, what did we do here? Okay, let's work this. So we know that our guaranteed analysis is 0.33, 0.46, and 0.60. Okay, and if you'd like, I think I'm going to add this in here because I want to do insert. I also want to do this in per field. And this is dollars. Wait, I don't. I want to put this somewhere else. I want to do it right here. I'm going to do this dollars per field. This is pounds per field. Okay. All right, and so we know that urea is going to cost this. That's awfully big. All right. Dollars per pound, this equals price over product, 700 divided by 2,000. And oh, don't need any of that there. All right, so rate over analysis, and we know that everything is going to end up being, so this is equals to our nitrogen divided by absolute analysis. So we need to make this an absolute, F4. And we need this to be this divided by our analysis for P, F4, or you have to add the dollar signs in if you're on a Mac. And this is equals this divided by 0.6 as F4, enter. There we go. There's all of our nitrogen. I like to have that centered. Looks like this needs a, there we go. Okay, and so then how many pounds per field? This equals this times, this needs to be F4 as well because we want to reference just that cell. this needs to be something different. We need to do this intentionally. We need to intentionally make this E3. That does not need to be an F4, but it does need to be intentionally written as E3. See how that moved down? If we had kept it, if we had made this an absolute, it would have always referenced this 5.14. But when we moved it down, you can see that it's going to keep going down the line for each one of those. So having an understanding of what the references mean is going to be important. Okay, so next, this is equal to, we can make this F4, and we can make this equals F, or T3, F4, and equals F4. Let's go all the way down. Okay, boom. Now, what is the total cost per acre? Now, this is where you have to do some math. This is where you have to do a lot of formulating, because this is the number of the pounds of urea times the cost per pound plus parentheses times the cost of the phosphorus plus parentheses times the cost of the potash. And that should bring us all the way down. Okay, and so since we know that we have it per acre, since this is a value per acre, right, because we've summed all of the costs for these, technically, we could do the same formula, which would be this times absolute F4 plus this times absolute plus this times this. I'm going to add one in here because I want to show you that if you wanted to, you could multiply the cost per acre times the number of acres. And they come out to be the same. So the math is the math. Drag all of this down, and if you drag all that down, they should equal the same as well. You can do it however you choose to, but you have to be able to know how to get inside and out what you're actually doing with your formulas. I'm going to go ahead and just copy this whole thing, or take this whole thing and bring it down to 2 decimal places. Boom. Center it. Looks clean. Okay, and so then now the total cost per acre we want to do the total cost per field. So our fertilizer is going to cost us about $36,000. Okay? We'll put this in yellow because we'll probably need this later. Look, we need a sum of acres as well. Let's sum the acres. Auto sum. Enter. We're going to need that for this. And we want to reference this as well. So we know that we need 1.25 pints per acre. So this equals this times F4 We always want to reference that cell. And we know that we need, I'm sorry. That's not what goes there. This is 141.2. Okay. Total product needed per gallon. So we know that this is, we need 1.25 pints. 1.25 pints times 141.12 acres divided by, there are 8 pints in a gallon. Right? 8 pints in a gallon. So we need 22 gallons. And each of these are sold in 2.5 gallon containers. So that means this is this. 22 gallons divided by 2.5, which would be about 10, right? We need about 10 of these jugs times $160.50. Let's try and see that here. 22.05, and this equals divided by 2.5. So about 8.82, and this equals 8.82 times $160 per thing, 114.61. 114.15.61. Drag this down because it's the same thing. I need that. Now, how many ounces per acre? This equals, this is actually gallons, so this is ounces times the acres divided by 128, because there's 128 ounces in a gallon. So we need 4 gallons, and we're probably going to end up buying 2 of these jugs because we only need, right? So, but to get it to an actual cost per acre, this equals divided by 2.25, or I'm sorry, 2.5 times $122. So the total cost for that was $201. This equals plus this plus this. There it is, this one. 44.75, 04.75. Following there.